Hello everyone, very good morning. Good morning. So, today students are taking so much time to join. I don't know what's the issue, but we should be starting at the time, right? So it has been already 10 minutes, sorry, 10 o'clock. So let's start with the class. So in yesterday's class, what we read is we read rotation. There is one question left from that portion. So first we will do that question, and after that we will move ahead with thermodynamics and KTG. ठीक है? So चलो पहले वो question करते हैं. So let's recall basically previous class through this question. So everyone take your time, do it. I'm launching the poll now. Yes. This is also a very simple question. You just need to apply things, right? Try to use all the information. There is a solid cylinder, mass. Okay, first you do it, then we will do it together. Anyone? Okay, I got one answer, but it doesn't look correct. You may check your calculation. Maybe there you're doing the mistake. Okay, let me end the poll now and let's solve it. Okay? Chalo. So what is the question given here? There is a solid cylinder of mass 2 kg and radius 4 centimeter. So mass is given, that is 2 kg, and radius is given. Radius is equal to how much? 4 centimeter. And this is rotating about its axis at the rate of 3 rotation per minute. So omega is given 3 rotation per minute. In yesterday's class also I told you SI unit of omega is radian per second. So basically whenever it is given in RPM and answer is given in SI unit, then you need to convert RPM into radian per second. Done it? So 3 rotation per minute means 3 into 2 pi divided by 60. One rotation means 2 pi radian. 1 minute means 60 seconds. So this will become how much? This will become pi by 10 radian per second. So omega we have got already. The torque required to stop after 2 pi revolution. So how many revolution it is able to complete? 2 pi revolution. One revolution means how many radian? 2 pi radian. And if somebody is going one round around a trajectory, it means it is covering how much angle? 2 pi radian. And if it is going round 2 pi revolution, number of revolution is 2 pi, then angle getting covered will be how much? That will be 2 pi is the number of revolution. In one revolution, 2 pi radian. So this will become this much radian. Okay, so this is this thing. Now we are asked how much torque is required. So कैसे solve करोगे इस question को? If you see here carefully, it is rotating already with 3 rotation per minute, and it is stopping after 2 pi revolution. So if you use third equation of motion, that is what? Omega square is equal to omega naught ka square plus 2 alpha theta. So finally, it is coming to rest. It means omega square is 0. Omega naught ka square will be how much? Omega naught is pi by 10. So pi by 10 ka square. And since this dog is able to stop the rotation, it means this alpha has a negative sign. I mean, if the body is rotating in a anti-clockwise sense, then torque is acting in anti-clockwise sense. Sorry, in the clockwise sense. So both are oppositely directed. It means alpha here is negative. So आप alpha को negative ले लो. 2 alpha we don't know into theta. Theta का value is how much? That is your 4 pi का square. So if you look here carefully, 8 pi का square alpha will be pi का square by 10. So this thing will get cancelled, and alpha is equal to how much? 1 by 80. If the calculation is correct. No, this is 100, right? So 1 by 800. ठीक है, कैलकुलेशन सही से देखना जो भी मैं कर रही हूँ. अब देखो कॉन्सेप्ट तो ये है, उसके बाद हमें निकालना क्या है? वी हैव टू कैलकुलेट टॉर्क. वी हैव कैलकुलेटेड अल्फा. टॉर्क और अल्फा कैसे रिलेटेड है? आई अल्फा. ठीक है. सो लीनियर, सॉरी, moment of inertia will be what? If you see here, this is a solid cylinder. So moment of inertia क्या होगा? mr square by 2. So you just do the thing. 2 into that is mass. Radius का square. Radius is 4 centimeter. So in SI unit लोगे meter. 0.04 meter, right? So this will become 4 into, sorry, no, 4 into 4 into 10 to the power minus 4, right? So this is mr square divided by 2 into alpha. Alpha is how much? 1 by 800. Okay. So if you go to solve it now, 4 into 2 will get cancelled with this. 2 into 2 will get cancelled with this. And this will become how much? 2 into 10 to the power minus 6. So correct answer will be which one? It will be first one. So question was not difficult. What was required is you should know how to apply the concept. ठीक है. So simply हमें third equation of motion, दो formula use हुआ. One formula was this and another formula was, and third important thing was that you need to be careful with proper unit thing, right? Whenever omega is given in RPM, convert it into radian per second. If rest of other things are in SI units. Okay? So please be careful with this thing. Anyone having any doubt so far? There was one student yesterday, he or she asked me something. I told him or her to join today's class a bit earlier, but he or she didn't. Uh, just now I want to ask, your doubt is still there or it got cleared? Let me know. I just forgot the name actually. Sorry. But if you're here, let me know. Yes. Okay. Clear हो गया? Uh, okay. This thing I will let you know. ठीक है? Chalo, let me talk with my team so that we can have a WhatsApp group. I will talk with my team today and will let you know tomorrow. Okay? Don't worry. Don't worry. If you're having any doubt regarding that, if you want it, then you can let me know here. We will do something. Okay? We will figure it out. Don't worry. So this is this thing. Now let's move ahead with what? Uh, KTG and thermodynamics. देखो ये topic बहुत interesting है. This topic is very much easy, very easy, and from here lots of questions come actually. So let's first revise through the concept. After that, we will do some questions. ठीक है? So first thing is first law of thermodynamics. जिस जो सबको पता है, first law of thermodynamics is what? It talks about energy conservation, sign convention, work done in different processes. I will just take you through the concept. So let's start. First law of thermodynamics क्या कहता है? If you have a system, gaseous system we are dealing with here, right? And if you are giving heat to the system, what system will do with the heat? Either it will eat heat to increase its energy, that is internal energy will change, or either it will do work. So whatever heat it is taking, it will divide that heat into two portions. and that is your work done and change in internal energy. So according to energy conservation, delta Q should be equal to W plus delta U. And this is the statement of first law of thermodynamics. And this is quite based on what? Energy conservation. So this thing you need to keep in mind. Now, here there are two terms, work done, sorry, three terms, work done, change in internal energy, and heat, energy given to the system here. So we need to deal with the sign convention. Whenever work is getting done by the system, okay? So work done by the system is taken as positive, and work done on the system is taken as what? Negative. Always remember this sign convention is just opposite with what you must have studied in your chemistry classes. Done. So this is opposite. In physics, our interest is to get work done by the system. And that is why whenever work is getting done by the system, that work done is positive, and when we are doing work on the system, it is negative. If you talk about heat, then if you are giving heat to the system, so if you are giving it, I mean, in physics, we need to give energy to the system so that it can give us work, right? So when you are giving heat to the system, that is positive. But if heat is getting released by the system, it is something we don't desire. So it is termed as negative. So heat given to the system, positive. Heat released by the system, negative. Remember this sign convention. उसके बाद है तुम्हारा work done. What is the general formula of work done? Work done ka general formula is PdV. So if we talk about isobaric process, process in which pressure is constant, and in this case, work done is P into V2 minus V1. If you talk about isothermal process, here temperature is constant, and in this case, work done is nRT ln V2 by V1 or nRT ln V1 by V2. Important thing is that whenever volume is given in meter cube or centimeter cube, pressure has to be in Pascal. Always keep things in SI unit. Okay? So SI unit of pressure is what? Pascal. Now, if you look here, nRT, here temperature ko always write in Kelvin while you are calculating this work done thing. That is important. Isophoric is what? Here volume is constant. And you already know if volume is constant, then there won't be work done because work done is PdV. So here work done is 0. And when the process is adiabatic ka matlab there is no heat exchange happening. That is delta Q is equal to 0 in this process. And here work done is what? nR T1 minus T2 divided by gamma minus 1. Gamma you must be aware of, this is equal to Cp by Cv. इसी चीज को, इसी वर्क डन को हम कैसे लिख सकते हैं? nRT1 को क्या लिख सकते हैं? P1 V1, क्योंकि PV इक्वल टू nRT होता है. सो दिस वर्क डन कैन बी रिटन इन दिस फॉर्म ऑल्सो. P1 V1 माइनस P2 V2 गामा माइनस 1. एडियाबेटिक प्रोसेस का जो जनरल इक्वेशन होता है, आप सब लिखे होंगे जनरल इक्वेशन. जनरल इक्वेशन इज PV गामा इक्वल टू कांस्टेंट. ठीक है? इन ऑल दिस प्रोसेसेस, आइसोबारिक, आइसोथर्मल, आइसोकोरिक, एडियाबेटिक, और व्हाटएवर इज द प्रोसेस, if there is an ideal gas, one equation is always correct, that is ideal gas equation, जिसको हम लिखते हैं PV equal to nRT. So PV equal to nRT is true or can be used for all of these processes to the uh, till the time gas is ideal gas. ठीक है? But PV gamma equal to constant is an equation specific to adiabatic process. ठीक है? चलो, नाउ इफ द प्रोसेस इज नथिंग, बट ये पोर्शन से क्वेश्चन तुम लोगों को काफी कम आता है, नहीं रिसेंट में दिखा नहीं है, बट आई हैव जस्ट टेकन हियर. जैसे एडियाबेटिक में एक्स इज गामा, बट इफ द प्रोसेस इज not falling under any of these four categories and the process is something different, जिसको मैं polytropic process बोल रही हूँ. And here I am saying कि इसका equation, general equation will be PV x equal to constant. So here work done formula will be same as adiabatic process, only difference is in place of gamma we are keeping here x. ठीक है? So just remember this thing. Again, this is not significant for your thing. So I just included in case you want it, but it's not required. Leave it here. ठीक है? यहाँ तक देख लो, इसको रहने दो. ठीक है? What is the second law of thermodynamics? In second law of thermodynamics, we have two statements. One is your Kelvin-Planck statement. ठीक है? One is your Kelvin-Planck statement. और ये statement क्या कहता है? This statement says that whenever on the if there is a system and you are giving heat to the system, so this system cannot convert whole heat into work. It will lose some heat to the surrounding. Then, so you cannot write here Q is equal to W. System won't convert whole heat to the work. It will release some heat to the system, surrounding, and rest of the heat it will utilize to do work. So Kelvin Planck said that Q dash cannot be equal to 0, Q cannot be equal to W. Done. And on this statement of Kelvin, we say that Carnot engine, whatever engine you devise, that engine cannot have coefficient, I mean, cannot have efficiency equal to 1. That I will explain a bit later. But Kelvin Planck statement ko samajh lo, you cannot convert whole heat into work. This is the thing. Next is your Clausius statement, and this is more common thing. I mean, here you don't need much explanation. Clausius simply said that you cannot allow heat to move from lower temperature to higher temperature. ठीक है? जैसे आप देख लो, अगर हमारे पास एक सपोज कर लो, yes, suppose there is a cup of tea, and suppose this is at temperature 25 degrees centigrade. ठीक है? And एक काम करती हूँ, just give me some second. Let's say this is cold coffee, and this is at 5 degrees centigrade, and this is our surrounding. It has a temperature of 25 degrees centigrade. What do you expect normally to happen? Normally, what will happen? This cold coffee will warm up, right? It will, after some time, come in equilibrium with the surrounding. That is, its temperature will become 25 degrees. Normally, this will happen then, but it cannot happen like this cold coffee will get more colder over time. It cannot happen. And if it is happening, it means what? It means from 5 degrees cold coffee, heat is getting transferred to the surrounding, which is at 25 degrees centigrade. So it means heat has to travel from low temperature to high temperature. But this is not possible because we have never seen it in our surrounding, right? We never saw cold coffee getting more colder. We always saw it getting warmer. We always saw hot tea getting more colder over time until its temperature is reaching up to 25 degrees. So Clausius का statement simple था, heat will flow from high temperature to low temperature. This was the statement. ठीक है? Now heat engine हमें पढ़ना है, थोड़ा question आया है यहाँ से. So what is this heat engine? Nothing but there is a system. We are giving certain amount of heat to the system. Q1 heat we are giving it. What it will do, we want system to do some work for us, so it is doing W work, but it cannot convert whole heat into work. So some heat it will reject to the surrounding. So Q2 amount of heat it is rejecting. So what will be the efficiency of engine? Efficiency is what? Output by input. And what is the output of this engine? What we want out of this engine? Work. So output is work. And what is the input? How much heat we are giving it? Q1. So this is efficiency, right? And here, since this process is cyclic, आपने पढ़ा होगा, this process used to be what? Cyclic. So if this process is cyclic, and if you apply first law of thermodynamics, delta Q is equal to what? Work done plus delta U. In cyclic process, change in internal energy is 0. So delta Q is equal to W. And if you see here properly, अगर sign convention से आप लिखो, you are giving Q1 heat to the system. So delta Q में plus Q1 is plus and Q2 is getting released. So that is negative. So this is this equal to W. तो W को आप क्या लिख सकते हो? Q1 minus Q2 by Q1. And here you can write 1 minus Q2 by Q1. So efficiency is what? 1 minus Q2 by Q1. And I have told you Q2 cannot be equal to 0 ever. It means efficiency cannot be equal to 1. Also, you must have seen that Carnot engine, which is the most ideal engine where efficiency is the highest. Obviously not equal to 1, but closer to 1. So from that particular diagram, efficiency को हम ऐसा भी लिखते हैं 1 minus T2 by T1. So efficiency का दो formula है. First is your 1 minus Q2 by Q1. Q2 is what? Amount of heat getting ejected. Q1 is what? Amount of heat being given to the system. T2 is what? T2 is the temperature of sink. That is low temperature. T1 is what? High temperature. ठीक है, यानी कि जिस टेम्परेचर से आप हीट दे रहे हो दैट इज T1, जिस टेम्परेचर को हीट इजेक्ट हो रहा है दैट इज योर T2. So that is basically called sink temperature. This is reservoir temperature T1. ठीक है, and always write T2 T1 in Kelvin whenever you are asked the question. So ये सारी चीजें याद रखना. ठीक है, if you talk about KTG, so in kinetic theory of gases, we are basically dealing with gases will carry what sort of velocity and all. So I will take you through that also. So let's revise it. Three velocities we have read: RMS velocity, average velocity, most probable velocity, right? So RMS velocity क्या लिखते हैं? 3RT by m, or it can also be written as 3KT by m. What is difference between these two? Here R is gas constant, m is molar mass. Always remember. K is Boltzmann constant. A small m is what? A small m is not molar mass. It is the mass of one a particular atom or molecule. ठीक है? So molar mass means mass of Avogadro number of molecule. Small m is what? One molecule का mass. And R and K are related. So R by N naught is equal to what? Is equal to K. ठीक है, so R को हम क्या लिख सकते हैं? R को हम लिख सकते हैं K in naught. This is the relation. I mean R is your gas constant, K is your Boltzmann constant. V average, again temperature को हमेशा Kelvin में लिखोगे whenever you will calculate the RMS speed. V average is what? 8RT by pi m, or remember the formula, most probably is 2RT by m. Here all the m are what? Molar masses. To the long here there is R, this m is molar mass. If there is K here, it means the m is what? It is mass of one individual atom or molecule. उसके बाद हमें मैक्सवेल डिस्ट्रीब्यूशन कर्व भी पढ़ना है थोड़ा सा. सो कर्व में ये ग्राफ किस चीज का है? इधर जैसे सपोज कर लो तुम्हारे पास एक कंटेनर है, एंड दिस कंटेनर हैज सो मेनी नंबर ऑफ गैसेस. देन नंबर ऑफ गैसियस मॉलिक्यूल को आप किधर लिख रहे हो? नंबर ऑफ गैसियस मॉलिक्यूल को आप वाई एक्सिस पे लिख रहे हो, और एक्स एक्सिस पे उन सारे मॉलिक्यूल का स्पीड लिख रहे हो. ठीक है, तो जब हम ग्राफ को ड्रॉ करते हैं ना, वी गेट कर्व समथिंग लाइक दिस. कुछ ऐसा कर्व हमें मिल रहा है. तो यहाँ पे अगर कर्व को ध्यान से देखो तो पिक जो वैल्यू है, ये वाला पिक पॉइंट है. यहाँ पे यहाँ पे सबसे ज्यादा नंबर ऑफ मॉलिक्यूल है, और उस मॉलिक्यूल का स्पीड इज व्हाट? दैट स्पीड इज वीपी, दैट इज मोस्ट प्रोबेबल स्पीड. With the name itself, it's clear it is that speed which is contained by most number of molecule in the container. So that is most probable speed. उसके बाद this is V average. So then is V average and then is your RMS. So अगर अगर आपको velocity का range बताना है, I mean which is smaller, which is larger, you can see here VP is the smallest, V average is in middle, and V RMS has the highest value. है ना? Because as we are moving towards the x-axis, velocity is increasing. So V RMS क्या होता है? सबसे greater होता है, उसके बाद V average होगा. Directly from here we have got the question, right? So this is the trend. Done है? So this is this thing. After that, equipartition of energy. We divide energy to each atom or molecule. So, and each atom and molecule has their own degree of freedom. You all must have studied. So each degree of freedom for a single atom or molecule have how much energy? Half kT energy. So if I say this atom has 3 degree of freedom, then each degree of freedom will have how much energy? Half kT. Half kT. ठीक है? Half kT. And this energy is for what? One molecule or atom के लिए. If you read the same thing for one mole of atom or molecule, then energy will become half RT. क्योंकि एक मोल के लिए आप क्या करोगे? दिस एनर्जी को n नॉट यानी कि एवोगैड्रो नंबर से मल्टीप्लाई करोगे, एंड k इंटू एन ए विल बिकम R. तो क्वेश्चन आया है, प्रीवियस ईयर भी आया है. ऑलवेज रिमेम्बर, एनर्जी contained in single degree of freedom for one atom or molecule is half kT. For one mole is always half RT. ठीक है, ये याद रखना. डिग्री ऑफ फ्रीडम फॉर मोनोएटॉमिक गैस के लिए डिग्री ऑफ फ्रीडम कितना होता है? 3. एंड ऑल दिस 3 आर ट्रांसलेशनल डिग्री ऑफ फ्रीडम. यानी कि if there is monoatomic gas, it can move along x axis, y axis, z axis. So it has 3 degree of freedom. So for one mole of monoatomic gas, how much energy will be there? 3/2 RT. ठीक है. उसके बाद है तुम्हारा डिग्री ऑफ फ्रीडम फॉर डायटोमिक गैसेस. इसके पास कितने डिग्री ऑफ फ्रीडम होते हैं? 5. 3 इज योर रोटेशन ट्रांसलेशनल एंड 2 इज योर रोटेशनल. ठीक है. सो टोटल डिग्री ऑफ फ्रीडम इज हाउ मच? 5. So if you have to talk about its total internal energy, then it will be how much? 1 degree of freedom has half RT for 1 mole. So 5 degree of freedom will have 5/2 RT. यानी कि 1 mole of diatomic gas at temperature T Kelvin will have energy how much? 5/T RT. ठीक है. So remember this thing. Now degree of freedom for triatomic gases. यहाँ पे 2 categories है. Always remember, triatomic gas can be linear and it can be non-linear. ठीक है. So if it is linear, it will behave like diatomic. So it will have total degree of freedom 5. If it is non-linear, it will have 3 translational plus 3 rotational. So it will have overall 6 degree of freedom. Remember it. ठीक है. कभी कभी क्या होता है ना, तुम्हारे क्वेश्चन में ये हो सकता है कि वाइब्रेशन टेम्परेचर ऑफ द सैंपल इज हायर एंड वाइब्रेशनल मोड इज एक्साइटेड. So for vibrational mode excitement, extra degree of freedom comes into account. ठीक है. And generally, you don't have to actually write the exact number of degree of freedom for vibrational mode, because I've never seen such questions coming. So yes, there will be degree of freedom coming for vibrational modes, and it will be certain variable. I mean, question ऐसा होगा जहाँ पे you can assume the variable and you can get the answer. So F degree of freedom. But if I talk about monoatomic gas, I can tell you how many will be there. अगर monoatomic है and if it is getting vibrated, if the sample temperature is higher and the atom is vibrating, then vibrational mode coming over here will be 2. ठीक है. 2 कैसे? क्योंकि जब भी कोई चीज वाइब्रेट करता है, what happens? It has potential energy. Potential energy होगा, है ना? क्योंकि when something is vibrating, then there will be what? There is SHM sort of thing, है ना? Vibrate कर रहा है, SHM sort of thing is there, oscillation sort of thing is there, so potential energy is there and also kinetic. जिस तरह से आपने SHM पढ़ा है ना, वहां पे कितने एनर्जी होते हैं? 2 होते हैं. One is your kinetic, another is your potential. Same thing will happen with vibrational mode. But this vibrational mode is not that simple with polyatomic gases. And again, that is not in your syllabus. So you don't need to worry about that. Monoatomic के लिए याद रखना, अगर मोनोटोमिक गैस वाइब्रेट कर रहा है, एडिशनल डिग्री ऑफ फ्रीडम कमिंग बिकॉज ऑफ वाइब्रेशन विल बी 2. ठीक है. अदरवाइज इट इज सिंपली सम वेरिएबल एंड दैट इज योर व्हाट? दैट इज योर एफ. उससे क्वेश्चन सॉल्व हो जाता है. ठीक है. सो यू डोंट नीड टू वरी अबाउट दिस थिंग. चलो आगे बढ़ते हैं. किसी को डाउट है यहाँ तक? एनीवन हैविंग एनी डाउट सो फार? चलो ठीक है. तो सीवी हम निकालते. सीवी कैसे होता है? 1/2 R. सो एफ इज व्हाट? डिग्री ऑफ फ्रीडम. मोनो के लिए लिखोगे तो सीवी का वैल्यू क्या होगा? 3/2 R, क्योंकि उसका डिग्री ऑफ फ्रीडम 3 होता है. डाया के लिए हो जाएगा 5/2 R. एंड ट्राइएटॉमिक के लिए विल डिपेंड ऑन लीनियर है या नॉन लीनियर. सीपी क्या होगा? सीपी माइनस सीवी क्या होता है? यू ऑलरेडी नो, दैट इज आर. सो इफ यू नो सीवी, यू कैन इजिली कैलकुलेट सीपी बाई एडिंग R, not 1. This is R plus F/2R. ठीक है. Gamma is what? Cp by Cv. So this is how we are getting it. Now, another type of question is जहाँ पे you are not given a sample which has just one gas. ठीक है. Maybe that has mixture of gases. Suppose it has N1 mole of monoatomic, N2 mole of diatomic. In that case, how you will calculate the CV of this whole sample? So CV mixture is written as what? N1 CV1. N1 is number of mole of monoatomic. CV1 is CV of monoatomic plus N2 CV2 by N1 plus N2. Similarly, CP you will calculate. If you know CV and CP, you can easily calculate gamma, that is CP by CV. ठीक है. अनदर थिंग इज मीन फ्री पाथ. यहाँ से क्वेश्चन डायरेक्ट आया है फॉर्मूला से. तो ऑलवेज रिमेंबर, मीन फ्री पाथ का फॉर्मूला क्या है? 1/√2 n pi d square. What is this n? N is number of molecule per unit volume. What is this d? D is the diameter of molecule. And what is this mean free path? It means if there is a container, there are gaseous molecules. So because of temperature greater than 0 Kelvin of this sample, there will be collision between molecules, but they won't be colliding always. Suppose they collided at t equal to 0 time, After collision, they will separate. For some time, they will move without collision. Done it? So whatever distance it spends without colliding, done it? That is called mean free path. And that time is called relaxation time. That we have studied in electricity also. So this is your mean free path. Okay? चलो. Now let's start with the question. अब देखो तुम लोग के पास फॉर्मूला है. It won't be taking you much time. So take your time, do it. I have launched the poll there. ठीक है, करो. ध्यान से देखो. Okay, whatever answer I have got cannot be true in any case. You're just going the wrong path, completely wrong. क्या कर रहे हो? Everyone, come on, do it. Okay, so far I got just one correct answer. Just one. And this question is the simplest. Okay, I'm ending the poll now. Two correct answers. चलो ठीक है. So, what is the question? Equilibrium state of a thermodynamic system is described by. How we describe the equilibrium system? You must have seen graphs, PV curve, so many graphs. You must have seen it at least. So, if you have seen it, and if there are 2 points given, what things are mentioned over here? अगर तुम्हें याद हो ना, तो यहाँ पे प्रेशर लिखा होता है, वॉल्यूम लिखा होता है, टेम्परेचर is written like this. We never saw, or you must have never seen it like these points. At these points, what is given is work done, heat, volume is sorry, volume not work done, heat, and uh yes, work done and heat. Is it given anywhere? I mean, how you describe the position of gas? Suppose Carlo, there is this container. There is this container. Okay. So how you will define its status? जैसे how you will define your position? You will say I am in a room located in this particular city, which is under this state, which is under this country. Like that, you will locate yourself. Done. So how you locate gases in this container? If it is kept, I will say that this gas is occupying V volume. This gas is exerting certain pressure on the container walls. This gas is having certain temperature. Done. We won't say this gas has this much capacity to do work. Can you define your capacity to do work? It can be anything. I mean, depending on how much energy you are consuming, how much glucose you are eating. If you're not eating, your working capability will simply drop down. So a state cannot be defined by work done or total heat. Done it? So VPT. Correct answer will be which one? A, C, and D. So A is this, C is this, D is this. This. Correct option is your D. Okay? These are very simple things, but very important. Chalo. Now do this. Okay, Charan, I will do this. Through this question also, I will explain things. ठीक है? उसके बाद, if even if you are having doubt after that, then you can let me know again. ठीक है? चलो, let us do this question together. ठीक है? चलो, 4 of you answered it correct. That's great. Let's read the question first. According to the law of equipartition of energy, number of vibrational modes of polyatomic gas with gamma given will be how much, right? So we are asked vibrational mode. Gas is what? Polyatomic. Gas is what? Polyatomic. So I have told you, any whatever be the gas, it can have three sorts of different degree of freedom: for translation, for rotation, and for vibration, right? So for translation, polyatomic will have three. For rotation, it will have three. And for vibration, we don't know, right? We cannot say. It's not monoatomic, we will say two, right? So let's say it is F. So it has how many degree of freedom? 6 plus F degree of freedom. So what will be the total internal energy of the gas? So if you write internal energy of the gas, it will be degree of freedom is this much. 1 degree of freedom is how much energy for 1 mole? That is half RT. So 6 plus F degree of freedom में कितनी energy होगी? 6 plus F into half RT. So this is the total amount of internal energy this particular polyatomic gas is happening. And we have learned already, internal energy change formula is always written as NCV delta T. We write it like this. Okay? NCV delta T. So if you see here, U को हम क्या लिख सकते हैं? NCV. Okay. I hope I have not done any mistake. It is NCV delta T, right? Sorry. Yes. This should be this only. So this can be written as NCVT. If I don't talk about the change, then T delta T will be T simply, NCVT. So यहाँ पे अगर आप internal energy, हमने एक मोल लिया है, right? So N will become 1. So here PV T is equal to how much? 6 plus F by 2 R T. Okay? So this T will get cancelled. We are getting here CV. CV is equal to what? 6 plus F by 2 R. We got CV, right? We can calculate CP. CP is what? Why I'm doing this much? Because gamma is already given. Gamma is gamma, right? CP by CV is gamma. So if we calculate CV, if we calculate CP, we can divide it and write it equal to gamma so that we can solve the question. So CP को हम क्या लिखेंगे? CV plus R. So this will become C6 plus F by 2 R plus R. This is CP, right? So gamma will be how much? According to the question, gamma will be CP by CV. So आप एक काम करो, CP by CV लिखो. कितना होगा ये? This is FR plus 2R. So 6 plus FR plus 2R, है ना? Divided by how much? Divided by 2. And this divided by how much? 6 plus F. 6 plus F R by 2. So this thing. And this is equal to how much? This is equal to gamma. So gamma is equal to how much? 6 plus F plus 2R divided by 6 plus F R. Okay? So we can solve this and calculate value of F in terms of gamma and R, right? So here answer is given. Okay, हमने कहीं कुछ गलती जरूर किया है जो कि यहाँ पे किया हमने ऐड करने में, ठीक है? So यहाँ पे ये भी 6R होगा, right? So here this whole will look this like this. R will get cancelled. So gamma is equal to how much? 6 plus F plus 2 divided by 6 plus F. Now you can easily solve it. and calculate F in terms of gamma. Okay, so that is what is done in this question. Anyone has any doubt here? जैसे इक्वी पार्टीशन में अगर तुम लोगों को डाउट हो रहा है ना, यू हैव टू डू नथिंग. इफ द गैस इज मोनोएटॉमिक, एनर्जी, हाउ मेनी डिग्री ऑफ फ्रीडम इट विल हैव? 3. क्लियर है? इफ इट इज डायटोमिक, 5. क्लियर है? इफ इट इज पॉलीएटॉमिक, and in polyatomic, if it is linear, then again like diatomic, 5. And if it is non-linear, and if nothing is given in the question, then you have to, जैसे यहाँ पे nothing was given about if it is linear or non-linear, so we have to assume it is non-linear. And in that case, degree of freedom will be 3 translation, 3 rotation, that is 6. And if it has vibrational mode, then extra F will come. So here total degree of freedom I have written as 6 plus F. Done it. Internal energy is always written like delta U is NCV delta T, U NCV T. So here what I did is I write the internal energy at temperature T. From there I calculated C, then I CV, then I calculated CP. I wrote CP by CV is gamma because here already given CP by CV is gamma. So then in terms of gamma, we can calculate what? We can calculate degree of freedom. Anyone having any doubt in this thing? If you're not able to understand it, I can explain again. Let me know. Sai, is it clear to you? Okay, Mari. Okay, sorry, I pronounced your name quite wrong. Sorry, ठीक है? फिर से explain करूँ. जैसे देखो. Okay, let me do it again. What is given here? Cp by Cv is given. Okay, Cp by Cv is given. And this is equal to what? Gamma. Done it. What else is given? Gas is polyatomic. And what else is given? Given is it has a vibrational mode of freedom. ठीक है? So how many degree of freedom it will have? कितना होगा? Okay, how to convert in terms of gamma? Last में पूछ रहे हो? ठीक है, I will do that till the last. तो यहाँ पे ध्यान से देखो, Cp by Cv गामा है. What we are going to do now? Okay, 8. You are telling what? What is this 8? Okay, let me know. So this is this, ठीक है? So if it is polyatomic and it has vibrational mode also, so how many degree of freedom? 3 translation, 3 rotation, and F vibrational. So total degree of freedom is 3 plus 3 plus F. Done. So this polyatomic sample of gas at temperature T will have how much internal energy? कितना? क्योंकि we need to calculate CV and CP in terms of F, degree of freedom, vibrational mode of freedom, right? Then only we will be able to calculate F in terms of gamma. Done it? So if you write internal energy, then that is NCVT will be equal to total degree of freedom 6 plus F by 2 RT. If I am considering N is equal to 1 mole. So T will get cancelled. N is becoming 1 mole. That is why here I have written half RT. Okay? So CV is equal to how much? 6 plus F by 2 into R. What will be CP? CP will be R plus CV. That is R plus 6 plus F by 2 R. ठीक है? अब आपको क्या करना है? CP by CV कर दो. So CP is how much? R को मैं कॉमन ले रही हूँ. So this will become 1 plus 6 plus F by 2 into R. This is CP divided by CV, that is 6 plus F by 2. This is R. So R will get cancelled. यहाँ भी मैंने लिख दिया, sorry. So this is gamma, right? If you solve it, gamma will become 8 plus F by 2. And this is how much? 6 plus F by 2. This thing will get cancelled. ठीक है? अब आप इसको क्रॉस मल्टीप्लाई कर दो. What you are going to get? 6 gamma plus F gamma will be equal to 8 plus F. So if you solve it now, what we have to calculate? F. So 6 gamma minus 8. 6 gamma minus 8 will be equal to F minus F gamma. right? So here it is 6 gamma minus 8 is equal to F1 minus gamma. So degree of freedom is how much? It is कहीं पे 2 miss हुआ है I guess in the calculation. Can anyone spot it? Yes, you need to recheck the calculation. Because correct answer given is your C. If I look at C, then this is what? F is equal to how much? You can write it like 8 minus 6 gamma divided by gamma minus 1. तो यहाँ से 2 कॉमन लोगे तो 4 minus 3 gamma होगा. But we are getting 8 minus 6 gamma. So there is some mistake, I guess, in calculation. Can anyone spot it? Sai, what was your doubt? Conceptually, it's correct. Anyone? Yeah. Anyone is able to spot it? सब कुछ एक जगह लिख दिया है ना, so maybe. Yes. Anyway, we can recheck later also. क्योंकि we should not waste our time in rechecking. किसी को doubt है conceptually? Anyone is having any doubt in this question? Conceptually? Don't worry, I will let you know the where it is wrong in the last. Sai, is it clear? Yes. Okay, चलो ठीक है. I will spot it. Mean time में ये क्वेश्चन करो पहले. Yes, Sai, conceptual. It's not there. You're not getting it, or it's correct. क्या कह रहे हो बताओ. Sorry, I couldn't get you actually. That is why I'm asking. Yes, not cleared. Okay. क्या गलती किया है? If you want me to tell you that, then I will tell you. Uh, okay, okay, okay. I got it now. Okay, anyway, मैंने थोड़ा conceptual भी mistake किया यहाँ पे. Let me clear it for you. Okay, एक काम करती हूँ. Yes. तो मैंने तुम लोगों को क्या बताया? तुम लोग कहाँ फंस रहे हो मुझे भी समझ नहीं आ रहा. नाउ पोलीएटॉमिक गैस है. यू हैव रेड दिस टॉपिक बिफोर, राइट? यू हैव रेड दिस टॉपिक बिफोर या नहीं पढ़े हो? देखो, अगर पॉलीएटॉमिक गैस है, अगेन सेम थिंग आई विल राइट. 3 डिग्री ऑफ फ्रीडम फॉर रोटेशन, 3 डिग्री ऑफ फ्रीडम फॉर ट्रांसलेशन, F डिग्री ऑफ फ्रीडम फॉर व्हाट, फॉर वाइब्रेशन. ठीक है. Yes, Charan, you can unmute yourself and you can speak because I'm not able to get you what you are trying to say. Doubt one, which doubt you're having? You can unmute yourself and you can tell me. No worries, you can unmute.
I have doubt regarding this topic, law of equipartition of energy.
Oh, you didn't read before?
But I didn't understand.
Oh, so देखो, जैसे what is this thing is like, if gas is moving, then I mean in which direction it is moving. If you are moving, you can move in X direction, Y direction. We cannot move in Z direction because we cannot fly. But gases in container can move in Z direction also. So that is why for translation, it has 3 degree of freedom. रोटेशन के लिए उसी तरह से हम लेते हैं, इफ देर इज डायटोमिक गैस इट कैनॉट रोटेट अराउंड इट्स बॉन्ड. यू आर अ केमिस्ट्री स्टूडेंट, you can understand. If something is moving around the bond, it will break. So around this x-axis it cannot rotate, but around y-axis and around z-axis it can rotate. So that is why for diatomic, 3 degree of freedom for translation and 2 degree of freedom for rotation. ठीक है. तो मैंने ये बोला, अगर तुम्हें इफ यू आर गेटिंग मोर कंफ्यूज, जस्ट रिमेंबर वन थिंग. इफ गैस इज मोनोएटॉमिक, देन हाउ मच फ्रीडम इट हैज? 3 फ्रीडम इट हैज. ठीक है. सो इसके पास 3 फ्रीडम है, एक्स एक्सिस में मूव कर सकता है, वाई एक्सिस, जेड एक्सिस. एंड each degree of freedom, each degree of freedom has how much energy? For 1 mole it has half RT energy. So here also it will have half RT energy, and here also it will have half RT energy. So total how much energy it is having? 3 by 2 RT. Done. So 3 by 2 RT for 1 mole for monoatomic. How it is looking like? It is looking like F by 2 RT. दिख रहा है ना? F is what? Degree of freedom. So translation में, if body is translating and it has F degree of freedom for translation, then energy will be F by 2 RT. Similarly for diatomic, if I talk about, अगर मैं diatomic की बात करूं, so it can translate in 3 directions. So 3 by 2 energy coming from there for 1 mole, and it can rotate in 2 directions. So again, degree of freedom for rotation is 2. So 2 into again half RT, because each degree of freedom has how much energy? Half RT for 1 mole. So this is this. And if you talk about triatomic, so triatomic के लिए मैंने तुम लोगों को बताया कि if molecule is linear, then it will behave like diatomic. That is, it will have 5 degree of freedom. So total energy for 1 mole will be 5 into half RT. And if it is non-linear, its degree of freedom will be 6. And in that case, it will have total energy, how much for 1 mole? 6 into half RT. This will have 5 into half RT. So this is what I am trying to tell you. If in case of vibration, if you talk about, so मैंने बताया कि vibration में for one vibrational mode, 2 energies are there. One potential, one kinetic. So if I tell you vibrational mode freedom is 1, it means how many energies it will have? ध्यान से सुनना. मैं कह रही हूँ vibrational mode अगर एक है, then I told you 2 energies it will contain, potential and kinetic. So if vibrational mode of freedom is F, then how many energies it will have? It won't have F into half RT energy. Because half RT is for one thing, right? F degree of vibrational mode means it has already 2 things, potential energy and kinetic energy, right? So in case of vibrational mode, you have to be careful. Same mistake I did here while solving the question. If vibrational mode is F, then how much energy it will have? Simply first multiply it with 2 and then you write half RT. Tab likhna hai. In case of translational mode, no worries. If it is 3, then energy is 3 by 2 RT. If rotation hai, no worries. If degree of freedom is 3, then energy is 3 by 2 RT. But if it is vibrational mode and that is F, then energy will be first you will make it 2F and then you will multiply with half RT. Because just now I told you some moments before that vibrational mode ka matlab 2 energy, potential plus kinetic. But translation ka matlab only 1 energy, that is kinetic energy. Rotation ka matlab only 1 energy, that is rotational kinetic energy. But vibration ka matlab 2 energy, potential plus kinetic. And that is the mistake we did here. Okay? I hope I am making you understand. Sai, is it clear? So how much total energy you will write here? Total energy, translation ka 3 by 2 RT, rotation ka 3 by 2 RT, and what about the translation? Degree of freedom. Okay, what about, okay. So what about vibration? Vibration के लिए आप क्या लिखोगे? 2F into half RT. यही 2 मिस हो रहा था, इसलिए आंसर गलत आ रहा था, ठीक है? So this 2 will get cancelled. And here you will get how much? This is 6 RT by 2 plus how much? That is FT. ठीक है? So this will become 3 RT plus FT. So F plus 3 are simple. ठीक है? And this is how much? This is F R लिखना, देखो मैं बार बार मिस कर रही हूँ, तुम लोग प्लीज कैलकुलेशन सही करना. दिस इज, एंड इसको हम क्या लिखेंगे? Since we are taking 1 mole, N is 1 already, and CV T. This T will get cancelled. So N is 1 mole, CV is equal to how much? CV is equal to R को common ले लो 8 plus 3 R. CP को क्या लिखोगे? Directly we are getting answer now, I guess. So CP is what? CV plus 1. So this will become how much? F plus 4 R. Gamma क्या है तुम्हारा? CP by CV. So F plus 4 by F plus 3. Now you can calculate it. Gamma F plus 3 gamma is equal to F plus 4. So gamma minus 1 F is equal to 4 minus 3 gamma. Okay, so this is the answer. This is how you will make it. This was the mistake we did, right? Okay, so we got exhausted in this question itself. चलो 2 मिनट बचा है, ये क्वेश्चन कर लेते हैं. इसमें तुम्हें 30 सेकंड लगेगा. Let's do it. ठीक है? Only 30 seconds you will require. You just need to look at the diagram. Answer is there. So I expect each one of you to answer fast. Yes, I got 3 correct answers, 4 correct answers. Very good. That is great. Yes. So here, what will be, I'm ending the poll now. So what will be the work done in process BC? In process BC, you can see what is constant. Volume is constant. And when volume is constant, work done को हम क्या लिखते हैं? Work done को हम लिखते हैं 0. So correct answer will be 1. Question काफी simple आते हैं. Let's do this question. After that, we will end the class. Yes, I correct. This question is also very easy. You just need to look at the diagram and a bit of calculation, just a little bit. Okay, I got 1 correct answer. Okay, I'm ending the poll now. What you have to do, this is TV curve. TV curve है, सबसे पहले ideal gas equation लिख लो. PV equal to nRT. So curve is TV. So try to see nRT is equal to PV. T is equal to what? P by nR into yes I. You have raised your hand. You can let me know. T equal to P by nR into B. Done. So here TV curve is a straight line. It means it has to be constant. So for each thing, what is constant? Yes, that's correct. What is constant? Pressure has to be constant because TV curve is a straight line. It means this whole is a constant. It means pressure is constant. So if pressure is more, slope will be more. And here for this P1, slope is more. This slope is little less than that. And this has a minimum slope. So P1 is greater than P2 is greater than P3. Simply from ideal gas equation we can get it. ठीक है? चलो फिर कल के क्लास में मिलते हैं. We will do left out questions for sure, and after that we will move ahead with next portion. ठीक है? Everyone take care of yourself.